Okay, 12.7. Slight typo here. This is surface area of spheres. And the objective should say students will be able to find lateral and surface area of spheres. We already did cones, so spheres. Okay, we have a couple things here. We got a sphere touching a plane at exactly 1 point. That means the plane is tangent to the sphere. We have a plane cutting through the sphere and making a circle. And then we have a plane cutting through the exact center of the sphere, and that is called a great circle. I'm using a new pen here, so bear with me as I get used to it. Great circle is the intersection of a plane and a sphere through the center of the sphere. Okay, let's go to the next page. And it says, each great circle separates the sphere into two congruent halves known as hemispheres. So, yeah, if you cut a sphere right in half, you'd get this hemisphere, and you'd kind of have this circle as a base then. So, before you didn't have a base, right, because it was circular all the way around, but if you cut it right in half, you get kind of a circle for a base. Alright, in the figure, point O here is the center of the sphere, and this plane R intersects the sphere in circle A, so you can kind of see circle A there. If AO is 3 and OB is 10, they want us to find the distance of AB. Well, think about this. This really just makes a right triangle, right? And this is 3, and this is 10, and so we just have to find that distance. That's it. Well, it's just a Pythagorean theorem problem, so we just say 3 squared plus x squared equals 10 squared. So we get 9 plus x squared equals 100. And we subtract 9 from both sides, and we get x squared equals 91. And therefore, we get x equals the square root of 91, which is also approximately 9.5. So that's all we have to do for a problem like that. I imagine you're going to see some problems like that where you're going to have to know that there are certain right triangles in there because it's going to be perpendicular to that plane. Alright, let's move on to surface area. This is more what we're going to focus on. Surface area of a sphere. Well, we talked about this in class, but basically, if you were to go around a sphere, and the idea of a baseball kind of resembles this, you would be able to fit 4 circles around a sphere. 4 great circles, too. So you take the area of a circle, which is just pi r squared, and you just multiply it by 4. And then that gives you the surface area. T equals 4 pi r squared. Simple as that. So if the great circle of a sphere has an area of 1.1, so here, look, they already give you the area of the great circle. We want to find the surface area of the sphere. Well, all you got to do is take this and multiply by 4. So we're going to say 4 times 201.1. Well, that answer is simply 804.4 inches squared. And that's it. That's all there is to it. So let's think about this next problem though. It says if the same sphere was cut in half, find the surface area of the hemisphere. Okay, well this is trickier. Because remember I said if we cut it in half in the hemisphere, we have this like circular base that wasn't there before. It's not like this thing is hollow, right? We're gonna still have this flat surface here that's a circle. So we're gonna have half of the hemisphere. So if I could kind of write this out, we're gonna have half of the sphere plus 1, and I'm just going to write GC for great circle. Well, the sphere, we said, is 4 pi r squared, and we're going to cut that in half by dividing it by 2. And one great circle is just pi r squared. Well, 4 divided by 2 is 2 pi r squared plus pi r squared gives us 3 pi r squared. So the actual surface area, because we have to include the outside parts, which we had in the sphere, plus this new part that was created when we cut through it. And that's a circle. So we just do pi, we add pi r squared to it, and we get 3 pi r squared. Well, remember we said up here that the great circle area was 201.1, and we multiplied it by 4. Here, the great circle, still represented by this pi r squared, is still 201.1. So we're going to multiply it by 3. So that means in this scenario, our answer would be 201.1 times 3, or 603.3 inches squared. So there's the answer to that problem. Alright, last one. It says find the surface area of a baseball with a circumference of 9 inches to determine how much leather is needed to cover the ball. Okay, in class, I had people find the exact... Oh, let's just rewrite that. It's so ugly. I had people find the exact area, exact surface area, because I think it's a little bit more challenging, and I just think it's better if you know how to do it. So, if you don't know how to find the exact, see if you can just find the actual area, but I'm going to show you the exact way. And then you can check and see if yours is equivalent to the exact answer. So, if you want to try it on your own, you should pause it now, but otherwise, I'm going to get to it. Okay, we know that the circumference is 9 inches. So, we're going to start off by saying C equals 2 pi r, which equals 9 inches. Wow. Okay, so if we wanted to get r all by itself, we would just divide by 2 pi, divide by 2 pi. Well, that gets these guys to cancel, these guys to cancel, and I'm left with a radius that equals 9 over 2 pi. And I'm just going to leave it like that. I know you guys get scared of fractions, but this is really the simplest way to do it. If I can just leave it like that, I don't got to get out a calculator. I don't have to do anything else. I just leave it exactly how it is. Okay, now let's think. Well, if I wanted to find the surface area of this baseball, I'd have to use the surface area formula. Well, that's T equals 4 pi r squared. All right, so let's just plug in what we know. Well, we know we got a 4, we know we got a pi, and my radius is 9 over 2 pi. So let's plug in a 9 over 2 pi. I know, my 9's ugly. And don't forget to square it. Okay, so we get T equals 4 pi, and 9 squared is 81. And 2 pi squared is 4 pi squared. That's an important part. You got to make sure you put a pi squared there. Okay, well, now we're ready to start doing some canceling, because see, I have a pi up here and I have a pi squared on the bottom, so I could take away one of those pi's. And I have a 4 up here and I have a 4 on the bottom, so I could take away one of those 4's. This leaves me with just an 81 divided by pi. And that's pretty much the exact answer. That's as exact as we can get. So we would say 81 pi inches squared. But now, if we wanted to go to decimal, we could do 81 divided by pi in our calculators, and we should get something like 25 point, I'll do a few decimals, 7.831 inches squared. So that's what the exact answer is when it's translated into a decimal answer. This is the actual exact answer. So I'm guessing if you didn't get the exact answer, if you rounded somewhere around here, like say you, instead of you said 4.5 divided by pi, and then you got let's see, 4.5 divided by pi is about 1.43. So if you would have rounded there and just said 1.4 or even just 1.43 and then just kept going with that as your radius, it would have changed everything. It would have changed all of this. So keeping it in exact terms helps us get the more precise answer. And that's always the best option in mathematics. You want to try and go for the most precise answer. Okay, that's it for 12.7. I'll see you guys on the next video.